So when we name organic molecules, the core of what we think about is just how many carbons form the chain or form the ring that we're looking at. So let's say I have something like this. And hopefully you're reasonably familiar with what this represents. And I'll review it a little bit. So let's say I have something like this. Let's say that that is the molecular structure right there. And so the first question you should be asking is, how many carbons are there? And some of you might say, wait, how is that even a molecule? And just as a review, the endpoint of every line represents a carbon. So that's a carbon, 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 that's a carbon. And we have 1, 2, 3, 4, 5, 6 carbons, and we have no double bonds. So if you have all of that information, you're ready to name this molecule. And before I actually name it, let me just kind of give you all of the different prefixes. So if you have one carbon, the prefix is meth. The prefix is meth. If you have two carbons, the prefix is eth. And it's good to memorize at least, up to about 10. And actually, it kind of repeats after that. If you have three carbons, the prefix is prop. Prop, like propane. And you've heard of ethane and methane. So you'll see all of that soon. 4, you're talking about bute. 5. And after 5, it kind of becomes the traditional prefixes that we associate with a lot of these numbers. So at 5, it's pent, like pentagon. 6, it's hex, like hexagon. 7 is hept. 8 is oct, like octagon. 9 is non. 10 is dec. 10 is dec. And then after that, it kind of starts to have a pattern here. And you're not going to really deal with things much beyond the teens, but I'll just write them down here just out of interest. 11 is undec. Undec. And for those of you who know French, I'm not one of them, but I know that one in French is un, or in Spanish, uno. So it's kind of 1 and 10, 11. 12 is dodec. Dodec, do or dos if you're speaking Spanish. For 2, dec for 10, 2 and 10. That's 12. 13, you could imagine what it's going to be. It is tridec. Tridec. 14 is tetradec. Tetradec. A tetrapod is something with 4 legs. And then after that, it becomes very systematic. At 15 is pentadec. Pentadec. Notice pent, 5 and 10. 16 is hexadec. 17 is heptadec. So it just goes on and on and on. I don't think I have to go away. It's hexadec, heptadec, octadec is 18, 19 is nonadec, and then 20 is actually iso. But we won't even go into that. This will probably serve our purposes. I mean, I could go up to, 16 is hexadec. So this is just how many carbons are in our longest chain. What I drew here is just one chain. So we can immediately, let's try to name it. How many carbons do we have here? Well, we have 1, 2, 3, 4, 5, 6 carbons. So we'll be dealing with hex as a prefix. And then to get, I guess, the postfix on this prefix, or the kind of the root, you look to see if there are any double bonds here. And there are no double bonds here. And if we have no double bonds in this carbon chain, we're dealing with an alkane. This is called an alkane, which is a general term for all of the chains of carbons that have no double bonds on them, or no triple bonds, all single bonds. So in this situation, you take hex for 6. So this is hex. And then, because it's an alkane, it gets the ane from alkane. So this is hex. This is hexane. Let's do another one. Let's say I have this thing right here. I'll draw. Let's make it even longer. So let's say I have that thing right there. So how many carbons do we have? We have 1, 2, 3, 4, 5, 6, 7 carbons. They're all single bonds. So it's an alkane. So this will be 7 carbons. It is heptane, because we have all single bonds. Now, if things form a chain, or if things form a ring, I should say, we put the prefix cyclo in front of it. So if I have, let me show you what I'm talking about. So if I just have 5 carbons, 1, 2, 3, 4. So 1, 2, 3, 4, 5. Okay, so that's 5 right there. I have 1, 2, 3, 4, 5 carbons in a chain. If I just have 5 carbons in a chain like this would be pentane. 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 But if I have 5 carbons, then they form a ring. So let me draw it. So it's 1, 2, 3, 4, 5 carbons, and it forms a ring. Let me make it a little bit, let me make the drawing a little bit better. So it's really, I'm just drawing a pentagon, but notice this has 5 carbons on it. I could draw the carbons here. Carbon, 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 carbon. And just as a review, what you don't see is the hydrogens they're bonded to. Each of these guys have 2 bonds, so they must have 2 bonds with something else, and those are going to be with hydrogens. And I'll draw it here just as a bit of a review, but you notice very quickly the drawing gets extremely messy when you draw the 2 hydrogens on each of these carbons. So it's little bit over. Maybe I shouldn't be doing that. But there you go. So it becomes very messy when you draw the hydrogen. So it's better to just assume that they're there. If we don't draw all 4 bonds of the carbon, the other 2 bonds are going to be with hydrogen. So here you might say, okay, this is an alkane because I don't have any double bonds here. All of these are single bonds with the carbon. I have 5 carbons, so you might say this is pentane. But you have to think about one more thing. It's in a ring, so we add the prefix cyclo to it. So this is, because it's a ring, we write cyclo, cyclopentane. Cyclopentane. So let me just break that apart. This tells us that we're dealing with a ring. You see that this is a ring right there. This tells us that we're dealing with five carbons. And then this tells us right here, the ane part, that tells us that they are all single bonds. All carbon carbon single bonds, no double or triple bonds. All single bonds. So let's go the other way. Let's start with the word, and let's see if we can figure out what the actual structure would look like. So let's say I have, let's say I have cyclononane. Cyclononane. So what is this telling me? This tells me I'm dealing with a ring. That is a ring. It's going to have a ring structure. It's going to have 9 carbons, 9 Cs, and then it's an alkane, so they're all going to be single bonds. It's all going to be single bonds. Single bonds. So if I want to draw it, I want to draw 9 carbons in a ring. It's not a trivial thing to draw. Let me try my best. Let's see. That's 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. That's about, well, let's see. Let me draw it. Let me try a better shot at it. So let's see. I have 1, 1, 2, 3, 4, 5, 6, 7, 8, and then 9, and then you can connect the last 2. So let me make sure that this is, and I could have drawn it better than that, but hopefully you can see all the edges here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So that is, we have, it's in a cycle, it's in a ring. I have 9 carbons, and they're all single bonded. So this is cyclononane, although there's probably better ways to draw that ring right there. So if someone were to tell you, someone were to tell you octane, octane. If someone were to tell you octane, and that word might feel familiar to you from the gas station, and they are literally talking about the molecule octane. And now you know, or at least you have a sense of what they're talking about. The oct tells you that you have 8 carbons. There is no cyclo in front of it, so it's not a cycle. It's just going to be a chain. And then the ane part tells you that they're all single bonds. So it's just going to be 8 carbons in a chain. 1, 2, 3, 4, 5, 6, 7, 8. It's just going to look like that. 1, 2, 3, 4, 5, 6, 7, 8. In the next few videos, we'll add more to these molecules and make the names even more complex.